Hello everyone. We, the students of KLE Technological University, were working on our engineering exploration course project, which was making a disk launcher under the guidance of Sanjeev Kavle sir. So here are the group members: Archit Kumar, Subramanya L. Bhatt, M.H. Sridhar, Aditya A. Patil, and Subhamay Mitra. Our problem definition was to design a precise disk launching machine. It should work on electricity and should be portable. It should be able to hold minimum 15 disks at a time and launch a disk in every 5 seconds. It should be able to change the launching angle. It should hold disk of 5 cm. The machine should have an indicator which indicates the status of the disk holder. It should be under rupees 4000. So next is our function tree. So we divided our whole model into three different parts. So the first subsystem was disk handling unit. So its function are holding the disk and storing the disk and turning the motor off when the disk holder gets empty. So the next subsystem was launching unit. So its function were striking the disk and changing the angle of launch. And the last, indication unit. Its function were indicate the power supply in the machine and indicate the status of the disk holder. So here are the functions of the subsystems. Disk handling unit, its function is to store the disk in the holder. So next is disk launching unit. Its function is pulling the striker to hit the disk, turning off the motor when the disk holder gets empty, changing the angle of launching. Next is indication unit. Its function is to show the power supply in the machine and to indicate if the disk slot is going to be empty. So next are the selected concepts. So for the first concept here we have a motor, and this motor when rotates, this rod with a rubber grip at the tip hits here, and this is the striker which hits the disc and then the disc get released. So in the next concept we use rubber bands. So this is the striker, we pull it back with the help of the DC motor, and when the DC motor pull it back and when it get released it hits the disc and the disc get released. So next we are using springs here. So here we are pulling the this framework back with the help of a DC motor, and when the DC motor releases it, the disc here get launched. And for the fourth concept, here we are using rubber grips at the tracks and here also at the center. So due to friction, when this rotates in high speed, the disc from here are dragged through the track and get launched.
We have made the disk launching machine, and I am going to introduce all the parts. This is a striker which is going to hit the disk for the launching. This is a stand on which we are going to place all the subsystems. This is a support which we have made for supporting the motor. This is a row motor we are going to use for attaching the gear and pulling back the striker. This is a support for a holder, disc holder. This is the gear which we are going to attach to the motor, and which is attached also to the striker and going to pull back the striker. This is a disc which we are going to launch. This is a disc holder in which we are going to fill all the disc. Now let us come to the assembly part. This is our entire model of the disc sewing machine. This is a motor which we have connected here. This is the gear and this is the striker. This is the disc holder in which all the discs are filled. This is maintaining some distance from this surface by the support like this. And whenever the motor is going to revolve and the gear is going to pull back the striker, at the time the striker is going to go front by the electricity, and the disc is going to be launched from the holder, and this is going to fly from here. This is our entire system like this. I'm going to show it like this. This is our model. This is a disk storage machine.
Circuit diagram and flowchart. For the model to run, we have to make certain connections. Here are some circuit diagrams. This is the Arduino board which we are using for our model. This is the circuit diagram showing the connection between the DC motor and the Arduino board. And the flowchart explains about how the DC motor works. This is the circuit diagram showing the connection between the servo motor and the Arduino board. This is the IR sensor circuit diagram showing the connection between the IR sensor and Arduino board. And the flowchart explains about how IR sensor works. This is the complete circuit diagram consisting of a DC motor, two servo motor, an Arduino board, and some of the resistor, breadboard, and IR sensor. Here the purpose of the servo motor is to change the angle, and the IR sensor is used to indicate whether the disc holder is empty or not.
Now I'm explaining about modeling of disk launching machine. That is, firstly, this input is connected to the IR sensor, and degree 1 is connected to the servo motors. That is servo motor 1 and servo motor 2, and this IN1 and IN2 are the inputs. Now let us see what happens in this chart here. That when the disk is placed inside the disk holder, that IR sensor receives that signal, and IR sensor receives that signal and it sends it to the DC motor. And after receiving the signal from IR sensor, DC motor starts to rotate. And when the DC motor starts to rotate, at the time even servo motor will also rotate. And the work of this DC motor is to change the to launch the disk. And this use of this servo motor is used to change the angle of the launching disk. And here we can change by total 2 degrees, that is 30 degree and 60 degrees. Firstly, this servo motor will be at initial position at 0 degree, and after 3 seconds it changes to 30 degree, and after 3 seconds it comes back to its original position, that is 30 degree to 0 degree. And after stage 3 it again changes its degree from 0 degree to 60 degree, and after 3 seconds it comes back to its original position, that is 60 degree to 0 degree. And
So after that we come for the bill of material. A bill of material or product structure is a list of the raw materials, sub-assemblies, intermediate assemblies, subcomponents, parts, and the quantities of each needed to manufacture an end product. In this project also, we need some of the materials like a DC motor of 60 RPM, two IR sensors, one breadboard, one Arduino Mega 2560, 50 jumper wires, foam sheets, double channel relay, acrylic sheet for making discs, rubber band, adapter of 12 watts and 2 amperes, a servo motor, and metal rods. After that, it's come the motor sizing. A motor sizing refers to the process of picking the correct motor for the given load. It is important to size a motor correctly because if a motor is too small for an application, it may not have sufficient torque to start the load and run it up to the correct speed. So, in our project, we are using a rubber band of weight 1.09 grams. Elasticity factor is 45. The radius of the gear is 0.0125 meter. Length of the band stretched is 0.1 meter. Then the force come up to 4.5 newton. And if we calculate the torque, it come up to 0.05625 newton meter. After that, we come for the functional specification. There are some functions with its specifications. First is storing the disk, and its specification is at the time the holder should be able to hold 15 disks. Second, setting the angle of launching using remote. In this, two servo motors is controlling the angles of launching. Thirdly is the pulling the striker backward. It is done with the help of a DC motor. Fourth, striker hit the bottommost disc of the disc holder. The striker is held by rubber band. So when it is pulled backward, it tends to return its initial position and hit the hit the bottommost disc so that it can be launched. Fifth is the disc holder show an indication if less than 5 discs is in the disc holder. This is done by the using of an IR sensor. Lastly, the DC motor stops rotating if there is no disc inside the disc holder. This process is also done with the help of an IR sensor, which indicates that the disc is empty and it will stop the DC motor. So that's all. Thank you.